Handling multiple catch classes. You can put two or more catch classes. Each catch block is an exception handler and handles the type of exception indicated by its argument in a program. We saw an catch class or a catch block in our previous example. What we can do is we can use multiple catch classes in our program, and we can use multiple exception handlers in each of those catch blocks. No code can be between the end of the try block and the beginning of the first catch block. We should understand that whenever we write a catch block, a try block, or a catch block, the catch block will always follow the try block. We cannot, for example, write any code between these two blocks. The runtime system invokes the exception handler when the handler is the first one matches the type of the exception thrown. So for example, if we are not sure or we might suspect that multiple kinds of exception might occur in a certain code, once we write that code in our try block and then we try to catch each of those kinds of probable exceptions in our catch blocks, then whenever the system encounters the type of the exception that has occurred in any of these catch blocks, it will throw that exception. That exception will be thrown. For example, if the exception is caught over here in this one, this exception will be thrown. If the exception is caught in this line, in this catch block, this exception will be thrown by the runtime system. It executes the statement inside the matched catch block. The other catch blocks are bypassed and continues after the catch block. So for example, if you are using the multiple catch blocks and the error has been handled over here, the exception has been thrown over here, then the following catch blocks will be ignored, these will be bypassed, and whatever the code after the catch blocks is, that code will be executed. Consider the following cases. For example, if there is no exception, then no catch block will be executed and will go directly to the code that is following the catch blocks. If there is an exception, number format exception, or maybe if there is uncaught exception, for example, if there is an exception in our code and none of these catch blocks were able to catch that exception, this might be one situation, and we might use general exception. We will look at these situations one by one in our following slides. And we can also mismatch the order of our exceptions, how our catch blocks. We will have a look at this as well. Case 1 was, for example, there is no exception. We have a try block, we have a string, and we are trying to convert that string into an integer. Number format exception is the kind of an exception that can occur in this case. If there was the error, then we might get this exception. And we are using two catch blocks. For example, this one is trying to catch the specific exception that might occur here. And then we are, to be on a safer side, we are using the general exception class that is the super class of all of these exception handler classes. If the error was not caught by this exception handler or this catch block, then there is no way that we can avoid the exception class, because all the exceptions will be handled by the general class, the exception class. Now in this case, apparently there is no exception. This code looks alright. There should not be any error. For example, we execute this. We go to the catch block that is ignored because there is no exception, and we go to the last line. So these catch blocks will be ignored, or these will be bypassed because there is no exception in the try block, and the code following these catch blocks will be executed next. Now the points to note over here are no exceptions occurs in the above program. The runtime system executes all statements within the try block. It skips all statements in the catch block. Since there was no exception in our try block, all the statements in the catch blocks are skipped. It continues to run with the first statement after the catch block. This line will be printed until the end. The second case was there was an exception. There is an exception. For example, we are trying to convert a string into an integer. We are using typecasting over here, but the value in that string is something that cannot be converted to an integer. In our previous case, the value in our string was something that can be converted into an integer. That cannot be done over here. ABACD is cannot be an error. Now we can catch this error by number format exception handler. Since apparently there is an error in this program, what should happen is once we encounter the error, the code will go to the catch block. If this catch block is able to handle this exception, then it will be handled by this block and it will bypass this catch block and go to the last line. If this catch block was not able to handle this exception, then we will leave the exception to be handled by this catch block, and the last line are the next statements following the last catch block will be executed. Now the points to note over here are if an exception occurs in a try block, the try block terminates immediately. We talked about this previously as well, that the point where the error occurs in the try block, the control of the program passes to the catch block that follows the try block. The Java runtime system scans sequentially for an exception type matching the exception that was thrown. If the type of exception that has been thrown over here matches this catching the exception handler class that we are trying to catch that exception with in this catch block, the Java will try to find that exception handler. By catching the number format exception, it executes the code in the matching catch block. If the type of this exception matches with the type of the exception handler class that we are using in that particular catch block, then it will throw that exception at this point. If it were not matching, as we will see in our upcoming examples, then we might go to the next catch block. And understandably, rest of the catch blocks are skipped and the control of the program goes to the lines or the statements following that catch block, and it continues running our program after the last catch block, try catch block. In the third case, if there is an uncut exception, for example, we have this program again that we are trying to convert a string value to an integer value, and we are trying to handle this exception with an array out of bound exception class. Now the error is a different type. The error is of number format exception, as we saw in our previous slide. The error has been, for example, encountered and there is no catch block that matches this error. Although we have used catch blocks, but these are the catch blocks. None of these catch blocks handles the kind of error that is generated by our try block. Now this is the point that we should note over here, is that using only the try and catch block will not secure our program against the exceptions. The right kind of exception handling is required to handle the right kind of the error. The kind of error that is occurring over here should match the exception handler that we are using to catch that error. Otherwise, our program will terminate as it was when we were not using any exception handling. Our program will terminate at this point. Exception is in the thread main Java for input string, etc. If no matching catch block is found, the Java runtime system will attempt to handle the exception by terminating the program. And this is the same case as we were facing when we were not using any exception handling. So we need to handle our exceptions with the right kind of exception handler. In our fourth case, that is the general exception. For example, we are trying to convert a string to an int, and we are using an exception handler in this catch block, arithmetic exception. And this might not be the exception handler that will catch the kind of error that is occurring over here. Now in this case, what we can do is we can use the general exception handler, that is the exception class. Now the kind of error or exception that will be thrown by this code is the number format exception, and the kind of handler that we are trying to catch that exception with is arithmetic exception. Now these will not match, but to be on a safer side, what we are doing is, if the error or the exception is not handled by this catch block or this exception handler class, then there is a general class that is the super class of all our exception handler classes that can and will catch this exception. This will be ignored. This catch block will be ignored because of the nature of the error that is being thrown. This error will not be possibly caught by this exception handler, but it will be caught by the general exception handler, and the code following this catch block will be executed. Against our previous case, we were using two exception handlers, but both of the exception handlers were not able to handle that exception. That led to the termination of our program. In this case, the exception will be handled by our general superclass, that is the exception class, and the code following that catch block will be executed. So now our exception matches this exception handler class, and the following this catch block, the statements following this catch block will be executed. The points to note over here are: exceptions are arranged in an inheritance hierarchy. For example, and we will see this in the next slide as well, a catch specifying an exception near to the top of the hierarchy, a very general exception, are matched with any exception in the subtree. So the superclass, for example, will catch any exception that is generated by our try block. The exception block or the exception class is highest or second in highest to in our exception classes after the throwable class that extends the throwable class, and all of these subclasses were directly or indirectly inheriting the exception class. Now if any of the subclasses is not able to handle our exception in the try block, then as we have seen that the general exception class or the super class will handle that exception. Now let's look at this our last case where we look at the order of catch clauses. For example, we have the same kind of code in our try block that will generate an error. Now what we are doing over here is that we are using a different order of handling these exceptions now. We are using the general exception class, that is the super class, before we are using the specific class that might be able to handle this exception. Now this exception handler is the right exception handler to catch this kind of an exception. But what we are doing over here is we are using the super class of this exception handler class, that is the exception class, to handle this exception. Now this exception class comes before the number format exception class in the hierarchy. In other words, exception class is a superclass of this class, and any object of this number format exception class will be an object of the superclass, that is in this case the exception class. That is why we might not be able to get to this catch block despite of the fact that this is the right catch block that will handle this exception, because of the superclass that we are using to catch that exception. Now the kind of message that we can get over here is that we are trying to catch an exception that has already been handled or caught by the superclass of this class. So if we are using the order of the catch classes in such a way where a superclass comes before our subclass in the hierarchy or in the order, then the superclass will catch that exception, and we will not be able to get to the code that is handling the exception using the subclass. So the points to note over here are: specific exceptions are derived from more general types. The number format exception is a specific exception that has been derived from the general exception class. Both the specific and general types from which they are derived will handle exceptions of the more specific types. And the reason for that is, since an object of this subclass will be an object of the superclass, that is why this catch block that is executed first will handle that exception or throw that exception before even reaching to the next catch block. So exception subclass, specific types of exception, must come before any of their superclass. So whenever we're trying to use multiple catch blocks, what we should do is we should use the specific exception handler before the general exception handler in the order. Otherwise, we will never get to the specific exception handler. If not, the program can't be compiled. Now we can look at this exercise and try to find the output of this code. You can see we are trying to convert a string to a number, then we are trying to divide a number by that number, and the kind of exceptions that we are trying to catch. You can run the program and see the output. The nested try catch block. In Java, a try statement can be inside the block of another try. For example, we have a try block, then we can write another try catch block inside this try block. This is the inner try block or the inner try catch block, and this is the outer try catch block. And there are situations where we might need this kind of nesting, where we insert a try catch block inside another try catch block. So this is our outer try catch block, and this is our inner try catch block. If an inner try statement does not have a matching catch statement for a particular exception, the next try statement's catch handlers are inspected for a match. So for example, if an exception is not handled by this inner try catch block, then the system will try to look for the exception handler in this outer try catch block. This continues until one of the catch statements succeeds or until all of the nested try statements are exhausted. So we will keep checking. For example, if there are multiple inner try catch blocks and if the exception is not handled by the inner block, then we'll keep looking for the catch blocks outside of this inner block. If there is a matching exception handler is found, then the exception will be thrown. Otherwise, the program will be terminated. If no catch statements match, then the Java runtime system will handle the exception. In that case, our program is terminated. For example, we have an example where an exception is caught by the inner try. We have an example where we have two arrays and we are trying to divide the elements of one array and the elements of the other array. So we have tried to handle a possible division by zero error inside the inner exception or the inner try catch block, and we have handled the possible array index out of bounds exception in the outer try catch block. So when we go through these array one by one, dividing the elements of the number array by the elements of the denom array, at some point we might get the division by zero error. So let's say in the first one the index is equal to 0, the index I is equal to 0, 4 is divided by 0, 4 is divided by 2, and there should be no error. Now when the index becomes 1 and the index I is equal to 1, at position 1 the 8 is divided by 0 in the denom array. So this is an exception that should be handled by this inner try catch block. Can't divide by 0. Throws at this point an exception should be thrown that 8 is divided by 0 when 8 is divided by 0, and the program will continue to the next iteration. The points note here are: the exception is caught by the inner exception handler when I is 1. It prints out the error message and continues to run for the next iteration. So when the I is equal to 2, what should happen is the number at position 2 at index 2 in the number array is 16. The element at index 2 in the array denom is 0. Again we have a situation where we are trying to divide a number by 0 and the error should be generated, and the program should continue to the next iteration where the I is equal to 3 at position 3 or index 3. In number array we have the number 32, the element 32. In the denom array we have the element 4, that is a divisible arithmetic. Then the program should complete at this point. Again the exception is handled when I equals 2 at this position when we were trying to divide the 16 by 0, and the error was handled by the inner try catch block. In this situation our errors were handled by the inner try catch block. And another example where we tried to catch the error by the outer try catch block. Again we have the same array, number array, and we have the denom array, and we are trying to divide the elements of the number array by the elements of the denom array. And when we try to do this, for example, when I is equal to 0, the element at position index 0 in the number array is 4, and the element at index 0 in the denom array is 2. 4 will be divided by 2 without generating any error by the inner catch block. But when the I is equal to 1, the element at position or index 1 in the number array is 8, but there is no index position 1 in our denom array. So we have run out of our index in this second array, and that is where the array index out of bounds exception should be generated, and that error or that exception will be handled by our outer try block. This error is not handled anywhere in the inner by the inner catch block. The inner catch block is trying to catch the divided by 0 error or the arithmetic exceptions, and the outer catch block is trying to catch the array index out of bounds exception, and that exception will be caught at this point in this catch block. The points to note here are: if no matching catch block is found in the inner block, as was in this case, the next catch handler in the outer try block is inspected for a match. What we did was, when we had the error was not handled in this inner catch block, we tried to look for the matching catch block in the outer try catch block. If no catch statements match, then the Java runtime system will handle the exception. If you are not handling this error over here, then the Java would have come in and handled this exception. But if a matching block is found, as is in our case, the system will jump out of the outer try block and the for loop. Now, when I is equal to 1, this program terminates because there is no elements, or the number of elements or the size of this array is 1, so there will be no second element in this array, and we cannot divide it by any element in the denom array. You can look at this example again and try to guess the output, or you can run the program and try to generate the kind of an output that this exercise or this example will generate. Try to go through the code by dry running the code first, guess the output, and then you can type your program, write your program, and generate the kind of output that you will get from this code.